Hi there, folks. Today we're looking at the discriminant, and the discriminant is really just a piece of our quadratic formula, but it's the most important piece. It's the piece that dictates what kind of answers we're going to get. All right. And so when we look at the discriminant, it's the b squared minus 4ac. It's that part of the quadratic formula that's under the square root. And so if we think about our quadratic formula off to the side for a second, remember it's opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right. And really, again, that thing under the square root is going to determine what kind of numbers we're dealing with. You know, if I take the square root of that thing and it comes out nicely, it means I'm dealing with nice values that I could have solved this thing by factoring, okay, which means I have rational answers. If I get things like a positive that's not a perfect square under there, then I get irrational numbers. Or if I get a negative, then I'm going to have an I that comes out, so I'm going to have complex solutions. And so the idea is that the discriminant, the thing under the square root, dictates what kind of answers we're going to have. And so if I just want to know what kind of answers we're going to have, what kind of solutions are we going to get, I can just use the discriminant instead of having to solve the entire quadratic, okay? And so based on the discriminant, based on that value, if I get certain values for the discriminant, I know what kind of answers I'm going to get. So if I get a 0 for the discriminant, it means I have one rational solution. It means I'm only going to get one answer. And really, again, if you think about that for a moment, right here, if I were to plug a 0 in for what's under the square root, watch how this simplifies. I get the opposite of b plus or minus 0 over 2a. Well, plus or minus 0 gives me the same thing. It's just opposite of b over 2a. All right. And so what happens is when I have a 0 for the discriminant, when I have a 0 under the square root, really I end up not having the plus or minus when it's all said and done. And the plus or minus is what gives me two separate answers. And so because it's a 0, I end up with just one answer, and that one answer is rational because it's a fraction. It's this idea of opposite of b over 2a. It's one value over another value. It's written as a fraction. Okay. This is the only scenario in which we get only one solution. Okay, because again, the 0 causes the square root to go away, which means no more plus or minus, so one answer. And the thing that I'm left with is a fraction, so it's one rational answer. Okay. If I get a perfect square for that value, it means I have two rational answers. All right. And again, the idea here is, if I were to kind of just come up with a fake example here, if I had something like a 25 underneath here, well, I could continue to simplify this without a calculator. That gives me a 5 over 2a. And then if I had values plugged in here for a and b, well, I could just take that b value, or the opposite of the b value. I could add the 5 and then divide by the 2a. And I would get a rational answer because I could express it as a fraction. Okay, I don't have a square root left anymore, so I don't have never-ending, never-repeating decimals. Okay, when I have a square root still stuck in here, that's an irrational answer. And so what happens is the square root goes away. That's why these are rational. If you go back to like rationalizing the denominator, means getting rid of radicals. Okay, it's that idea of rationalizing, no more radicals. That's what happens. We get a perfect square here. All right, but notice the plus or minus didn't go away, so I still have two answers. Okay. The next one, if I get a positive that's not a perfect square, so once again, a positive that's not a perfect square, let's say I had something like the square root of 5 this time instead of 25. Well, I can't simplify that any further, so basically, I'm going to have a square root in my two answers. I still have the plus or minus, so I still have two answers, and I still have that square root in each of those answers, so it's going to be two irrational answers, two irrational numbers, never-ending, never-repeating decimals, okay? And then if I get a negative, if I have a negative under the square root, I get imaginary answers. We call these complex answers because they have a real part and an imaginary part. So again, if I have something like this guy, sorry, I was writing in green. I got to keep that going. Felt really good. If I get something like the square root of negative 2 or something like that, as I were to simplify this thing, I still have the square root, and that doesn't matter, but I have that I on the outside. Okay, as soon as I have that I on the outside, I have an imaginary number on the outside. Now I'm dealing with complex answers. I still have two solutions because I still have the plus or minus, but now each of those solutions is going to have an I in it. Each of those solutions is going to involve imaginary numbers, so they're complex solutions, okay? That's what we call numbers that have a real number part and imaginary number part. So if I had something like 5 plus I, That's a complex number because the 5 is a real number, the I is an imaginary number. And so all of these solutions end up looking like this when I have those i's in there. When I have those imaginary parts, I get these complex solutions, okay? So again, even without solving, I can determine what kind of answers I'm going to have. Now, let's say you forget the discriminant. You forget all about this thing and you are asked what kind of solutions you're going to have. Well, you could just solve the quadratic. Go through your progression. Build a bridge. If you can solve by factoring, you solve by factoring. All right. If you can't solve by factoring, look for an a value 1 and b value z, and you solve by completing the square. Or if none of that works, use the quadratic formula. And then once you're done, look at the answer you get. If you get answers that look like this, x equals 5 and negative 1, well, that's 2 rational answers. If you get answers that look like this, plus or minus the square root of 2, well, that's 2 irrational answers. Or if you got answers that looked like this, well, that's 2 complex answers. And so you could actually just solve the quadratic completely, look at what kind of answers you get and say, oh, I have this many answers, plus or minus 1 or 2 answers. And then what kind of answers? Do I have radicals? Is it irrational? Do I have imaginary answers so they're too complex? Okay? So even if you forget the discriminant, you can always actually find the solutions and determine what kind of answers you have. So if I just do the discriminant here, again, b squared minus 4ac, so the b value is a negative 4, so b squared minus 4 times a, which is 2, times c, which is a negative 12. And I'll just simplify. That's a 16. That's going to be a plus because I see the 2 negatives in there. All right. And then from here, let's see, that's going to be a 96, it looks like. And now I add these up. It's like a 112, okay? And so now I have to interpret that answer. It's not just about finding the discriminant. I have to interpret the answer here. So I have to look at this thing and I have to say, okay, what kind of number is that? Is that a positive number, first of all? And the answer is yes, it's a positive number. Is it a perfect square? And the answer is no, it's not a perfect square. So I have a positive number that's not a perfect square. So it's positive, so I'm not going to have complex solution. But it's not a perfect square, so I'm going to still have a square root in this thing no matter what I do. So the answer here is that I would get 2 irrational answers. Okay? So if I just wanted to know what kind of answers I'm going to get, 2 irrational answers. Okay? If I look at the next one, same kind of thing. So b squared minus 4ac, so here's b squared minus 4 times a, which is a 1, times c, which is an 8. And I would just simplify. See, that's going to be a minus 32. And here's the thing, even before you subtract, you can tell that this is going to be negative. So even if you don't write down the negative 23, all right, the discriminant, yeah, we want that negative 23, but we already know what kind of answers we're going to get because it's a negative. Because I have a negative under the square root, I'm going to get imaginary numbers, which means I'm going to get 2 complex solutions. And again, they're complex because each of the answers has an imaginary part to it. Okay? But again, there's still 2 of them because the plus or minus is still there. It's still involved. All right? If I look at this one, and this is gets a little bit different here because as I go to write this down, I need A, B, and C, but I don't have A, B, and C the way this is written, okay? Because the discriminant is part of the quadratic formula, we have to approach it the same way. Make sure that this thing is written so that the whole thing is equal to 0, okay? Make sure it's written like this first. And now we can do our discriminant. Now I can see the actual A, B, and C values. So let's see, b squared minus 4 times a, which is 1, times c, which is 9. That's 36 minus 36, which is 0. So my discriminant is 0. Well, if I have a 0 there, it means that the plus or minus isn't even going to be there anymore. So it's only going to be one solution, and that solution is going to be rational because it's going to be expressed as a fraction. So one rational solution. If I look at the next one, we're in the same kind of situation. It's not written correctly. I can't do the discriminant if it's not set equal to 0, so I rearrange it. And make sure you write it in the proper order, the ax squared plus bx plus c. We want the x squared, then the x, then the constant term, descending order. Okay? And now I can do the discriminant, b squared minus 4ac. And I simplify, that's a 49. That's a minus 24. So it looks like that gives me a 25. And that is a perfect square, which means if I take the square root of that, I get a 5. Now I don't have any square roots left. Well, I still have the plus or minus, so I'm going to get 2 answers, but each of those answers is going to be a nice, neat answer. It's going to be 2 rational answers because I won't have any square roots left because I got a perfect square for my discriminant. Okay? And really, if you had looked at the original problem, once we have it set equal to 0, build a bridge. 2 numbers that multiply to a 6 but add to a -7, or a -6 and a -1. That's the other thing about rational equations, is they can always be factored. Look at the previous one, the one rational. Build a bridge. 2 numbers that multiply to 9 but add to a 6, or a +3 and a +3. I'd be able to factor that one. Okay? So solutions that we get when we're able to factor are always rational. All right? And solutions where we have to use completing the square and quadratic formula are typically, or always, as they couldn't be factored, are always going to be irrational or complex. Okay? If I look at this guy, again, get it set equal to 0 first. And now from here, let's go ahead and do our discriminant. B squared minus 4ac. And I simplify, that's a 25. Here, that's going to be a plus 48. And then the 25 plus 48 is a 73. And again, that's a positive, but it's not a perfect square. So positive that's not a perfect square, that's going to be 2 irrational solutions. Okay? And again, if you had tried building a bridge there, you find out that, well, you can't factor it. So now you know it's either going to be irrational or complex. You still have to go the route of either solving it with completing the square of the quadratic formula or finding the discriminant to determine whether it's going to be irrational or complex. And then if I look at this one, again, you could build a bridge here. And right away, if you build a bridge, 2 numbers that multiply to -1 but add to a +7, it's not going to happen. All right? There are no 2 numbers that work there, which means it's not going to be rational. So it's either irrational or complex here. So let's see. B squared minus 4ac. Sorry, let me switch back to blue. So that's a 49. That looks like plus 4. That's a 53. So once again, I have a positive that's not a perfect square. 2 irrational. Okay, so again, the discriminant is just a quick way to determine what kind of answers am I going to get here. Okay, and as we look at that thing, we just have to think about, all right, what does the square root do? What does that tell me? All right, if I get a 0, it means I'm only going to get one answer, no more plus or minus, and it's going to be rational. If it's a perfect square, the square root is gone, so rational answers, but I still have the plus or minus, so 2 rational answers. A positive that's not a perfect square, I'm going to have the plus or minus, so 2 answers, but they're going to be irrational because of the square root. And if I get a negative under that square root, that comes out as an imaginary number. Now I have 2 complex solutions. Okay?